Okay, guys, last time we talked about uh, adding and subtracting. We kept it restricted to just whole numbers, right? We had positives and negatives. Now we're going to throw fractions in the mix. So when fractions have the same denominator, we call that a common denominator, and it makes them like fractions. Okay? So for example, here's a couple of like fractions because they both have a denominator of 4. That's a common denominator. Even if it's a variable of an x, right? That's a common denominator. When fractions have different denominators, they're called unlike fractions. Like here, 9 and an 8, a 3 and an a. Different denominators are unlike fractions. To add and subtract like fractions, you can only add or subtract fractions when they have a common denominator only. Your denominator, by the way, can't be 0. That's going to be a recurring theme for us also. You can't divide by 0. Denominators can't be 0. Remember, a fraction bar is just a division symbol. So because you can't divide by 0, you can't have a denominator 0. So first of all, as long as our denominators are the same, the first thing I'm going to do when I notice that I have fractions, well, for one thing, if any of my numbers are fractions, I probably want them all to be fractions. Okay, but then I look at my denominator. If it's the same, then that's just going to be the denominator in my answer, and you either add or subtract depending on your sign numerator. So 1 plus 3 is 4, and it goes without saying, you always have to simplify fractions. Now, most of us probably realize that that'll simplify to 1/2. Okay? But when they get a little more complicated, then, and particularly when we have variables and not just numbers, letters, let's look at the method that we originally learned. With numbers, we get these shortcuts, right? And if we get familiar with it, we can just write 1/2. But really, what we would do is we're going to change each number in the numerator and the denominator into all of its factors. So because 4 is 2 times 2, and 8 is 2 times 2 times 2, and then anything that's the same in a numerator and a denominator, any factor that's the same, we can divide out. So notice there's a 2 left in that denominator, and if everything cancels out, that doesn't mean there's a 0 there. It means there's a 1, because we can always multiply by 1. I can put that anywhere, right? But since it doesn't change it, we don't have to write it, but there's always a 1 if everything else cancels out. Okay? Now, you might say, well, how did you know that was 2 times 2 times 2? We have something called the factor tree. So you take your number and you find any 2 factors. Okay? And then once you can't find any more factors, you stop. But if you can have more factors, you keep going. We're going to use this repeatedly, so it's a good thing to go ahead and start using. And that's how I know, oh, it's 2 times 2 times 2 for the factors of 8. Okay, notice we did not add the numerators, right? Don't add the numerators. This is 1/4, which is not the same thing that we got the 1/2. Okay, it doesn't work. You find a common denominator, you keep that denominator, and you only add or subtract the numerators. All right, so I'm looking at these. They already have a common denominator. That's a 10. So I keep it as a 10, and then I just subtract across. 3 minus 7. Hey, signs are different. That means minus. So 7 minus 3 is 4. Keep the sign in front of the bigger number. Okay? Now, we might already know how that simplifies. For those of you that do, great, you're just ahead. For those of us that don't, we're going to write, and while they're easy to find the factors, I'll just write them. Okay, we're going to write all of the factors of each numerator and denominator, and any of them that's the same, you can divide out. So final answer, negative 2/5. Don't forget about that negative. Don't forget pieces of your problem. Okay, look at these denominators. It doesn't matter what our denominators are. As long as they're the same thing, then I keep that same denominator. And then I have 5 minus 2, which is 3. And because I don't know what x is, I can't simplify that any further. Now, if we have unlike fractions, denominators that are not the same, then we got to find a common denominator so we can make them the same. So notice for the fractions 1/2 and 1/3, that denominator would be 6 because 2 goes into 6 evenly and 3 goes into 6 evenly. Okay, now 12 is also a common denominator for 1/2 and 1/3 because 2 and 3 both go into 12 evenly, but we like to find the least common denominator. It's not saying you have to, but it's going to make your work a lot easier, particularly when we have variables in those denominators like we saw just a second ago. So we're going to try to look for the least common denominator. Okay, so we're going to practice just finding the least common denominator. And when we have just numbers, we can get a shortcut. Okay, a shortcut is look at the biggest denominator. By the way, your common denominator will always, it has to be at least as big as the biggest or bigger. A lot of times people mistakenly look at these and say, oh, it's 3. 3 is the common factor, right? 3 is the common factor. I need a number that 3 goes into and 9 divides into. So it's got to be 9 or bigger. So the first thing I'm going to do, the shortcut when we just have numbers, is I'm going to see, is it the biggest number? Does 3 go into 9? Yes, that's my denominator. If it didn't go into 9, I would go up a couple of multiples of 9. 9 and 9 is 18, then 27, and try that. Okay, so we get a little shortcut with numbers, but while we're starting out easy here, let me go ahead and show you the method we're going to use to get a common denominator if I can't tell, if the numbers aren't quite so easy. Okay, so we're going to do our prime factorization like we were just talking about. Once you get a number that doesn't have any other factors besides 1, you stop. So 9 is 3 times 3. And 3, the only way I can write 3 with any factors is 3 times 1. Okay, to find the least common denominator, once you see all your factors spread out, you take anything they have in common. And because both of these have a factor of 3, I would take that 3. And then if there's any extra ones left over, like this 3, I'm going to take it also. Okay, notice we got 9, like we already knew that it was, right? Okay, but here's our method. So we're going to practice that. They're going to build up and build up a little bit, but we'll keep practicing this in addition to showing the shortcut so that we have both options available. Okay, same thing. We're just finding the common denominator right now. So 8 and 6. Okay, for my shortcut, if I just have numbers that's easy to deal with, I'm going to check the biggest one. Does 6 go into 8? No. So what about 8 and 8, 16? Does 6 go into that? No. 3 8s is 24. Hey, 6 goes into it. So I know, we might know, that that common denominator is 24. Okay. If I'm not sure, let's write our factor tree and see what all of our factors are. So this one's 2 times 2 times 2. Over here with 6, it's 2 times 3. All right, so to get the least common denominator, I take anything they have in common. They both have a 2. I'm going to take that. And then I go back, and if there's anything extra that I haven't taken, I'm going to take that also. And this right here is my least common denominator. Notice what this is. This is 4 times 6 or 24. Okay. Doing our least common denominator like this is also going to help us make those equivalent fractions that we need to actually add the denominators. Okay, 12 and 18, our numbers are getting a little bigger, notice. But a shortcut is it 18? Does 12 go evenly into 18? Remember, it's got to be the biggest one or bigger. 12 doesn't go into 18. 18 and 18 is 36. Hey, 12 goes into 36. So in reality, when we have easily manageable numbers, we get a shortcut. All right, what if I couldn't find it? 12, I'm going to say is 3 times 4. And if you wanted to start with 6 times 2, that's fine. In the end, you're going to get the same number because we're going to keep going until we can't go any further. So this is 2 times 2 times 3 for 12. And 18, 3 times 6, 9 times 2, however you want to do it. Any factors will work. Okay, so they have a 2 in common. I'm going to take that. Okay, they also have a 3 in common. So I'm going to take that. All right, now this one has an extra 2, and this one has an extra 3. Notice what we have here, 6 times 6, or 36. Okay, what does 15 go evenly into 70? I might not even know that answer. I mean, I do, because I do this all the time. You might not, so you might already be stumped. But if it doesn't go into 70, 70 and 70 is 140. Does it go into 140? I don't know. My easiest way here is to fall back on our method. Right? So 3 times 5, as far as I can go on both of those. 70, anytime a number ends in 0, hopefully we realize, oh, that's going to be something times 10. So 7 times 10, and then 5 times 2. So 2 times 5 times 7. Okay, they have a 5 in common, so I'm going to take that. Okay, this one also has a 2 and a 7, so I would take everything that's extra, and this one has an extra 3. Okay, so what do we have here? 10 times 21, or 210 is our least common denominator. So notice, even when the denominators are a little large to be very manageable, with this method, I always have a way to get my denominator fairly easily. Okay, so now we're going to move to how do I actually add and subtract them. First step, find the least common denominator. We've been practicing that. We know how to do it. We've got to rewrite each fraction as an equivalent fraction with that least common denominator. And then once the denominator is the same, we know how to do it. We've already had a few of those. Okay, so is 6 my, they're not the same. First thing I do, are the denominators the same? If they are, I'm golden. But they're not the same, right? So I check the biggest one. Does 4 go into 6? No. Well, 6 and 6 is 12. Hey, it goes into 12 though. 12 is my least common denominator. So I need to rewrite both of these fractions that have a denominator of 12. And the way I do that, as long as we do the same thing to the top and the bottom, the numerator and denominator, right? It's equivalent, because if I had, let's say we had our 3/4 and I multiplied the top and the bottom by 2, notice, oh, anytime anything's the same, we can cancel it. So it's kind of like the opposite of simplifying. Okay, so I need that denominator to be 12, though. I need that denominator to be 12. So I have 3/4 minus 5, 6. And what I think to myself is, well, what do I have to multiply 4 by to make it 12? Well, that would be 3. Once I figure that out, I just have to do the same thing to the top. What do you multiply 6 by to make it 12? Well, that would be 2. So once I figure out what I'm multiplying the denominator by, same thing to the top. Now notice over here, if we had gotten this from our factors, we would have had this. And then I can tell what to multiply by. Oh, I already have 4. I already have this part. I need a times 3. Over here, I already have 6. I would need to add the factor of 2. Okay, now that makes this 9 over 12. And this one 10 over 12. Now, once the denominator is the same, it stays the same. And I just do 9 minus 10. Signs are different means minus. 10 minus 9 is 1. Keep the sign in front of the bigger number. No, the 10 twelfths, right? But all I really have to consider is the 9 and the 10. I've already dealt with my denominator. Even though 10 twelfths is bigger than 9 twelfths, I just have to really compare the 9 and the 10 after they have a common denominator, that is. Okay. Oh, the denominators are not the same, so I've got to make them the same. It's got to be 12 or bigger. Does 9 go into 12? No. 12 and 12 is 24. 9 doesn't go into 24. 12 times 3 is 36. It's 36. I could go back and find it by my factor tree, and I'm sure in a minute we'll have some to do like that. Or when the numbers are small, I kind of get a shortcut. So I've got to make each one of these fractions have a denominator of 36. That means my question is, what do I multiply 12 by to make it 36? That's a 3. Once I figure out what I'm doing to the bottom, I do the same thing to the top. 9 times 4 is 36, so that's what I have to do to the numerator. Now that makes this fraction negative 15 36, and this one is 20 36ths. Hey, they got the same denominator now, so that just is my denominator and my answer, and I add and subtract. Signs are different, so minus. 20 minus 15 is 5. Keep the sign in front of the biggest number. This won't simplify either. There's no common factors. All right, 5 doesn't go into 36. So I'm finished. Okay. They don't have a common denominator, and it's not 20 or 40 or 60 or 80 or 100. Okay, here's one where I might need some help. So I just come over here. 16 is 4 times 4. 4 is 2 times 2. And 4 is 2 times 2. Okay, so this one is 2 times 2 times 2 times 2. 20, I can write as 5 times 4, and 4 is 2 times 2. So this one is 2 times 2 times 5. All right, I'm looking for my least common denominator. So they have a 2 in common. Okay, I'm going to take that. There's another 2. I'm going to take that. Oh, no more 2's. So this has an extra 2, 2. This has an extra 5. Anytime I get a 5 and a 2 that can multiply, I'm going to group those together. Now you might notice you can do this 2 at a time, but this is 4 times 2. So this is 8 times 10. Hey, it was 80, right? We just didn't know 16 went into 80. So I've got to make both of these 80. Which, now that I have my factors up here, isn't going to be hard to do. Like I said, we missed the fact that 16 goes evenly into 80, so maybe I'm thinking, oh, what number is that? But my 16, right, is the 4 2's. 1, 2, 3, 4. So the only thing extra that made this 80 was that 5. Okay, 20 looks like this. 2 2's and a 5. So that's right here, 2 2's and a 5. So the extra part is 4. Okay, so all fractions, we just break them down exactly the same. Now, you might have to go over to the side and see what 13 times 5 is. It is 65. And then I already know 16 times 5 is 80 because that was my goal. 3 times 4 is 12. And I already know that's 80, again, because that was my goal. Now my denominator is the same, so it's going to stay the same. The signs are the same, so that means plus. So if I add 65 and 12, I get 77, and keep the sign in front of the larger number. Now, I need to try to simplify that. We go back to the same idea. 77, though, is just 7 times 11. That's the only numbers. So in order for this to simplify, 80 would have to be either divisible by 7 or by 11. And look, I've already got 80 up here. There's not a 7 or an 11. So that's how I know that that's simplified. So doing this way, right, it's not that much work, and we can refer to it and get lots of help if we have it written out this way. Okay, so we want to make sure that we can do those kinds of things. All right, remember what I said earlier. If any of my numbers are fractions, I want them all to be fractions. And any whole number can be made a fraction by simply putting it over 1, because 4 divided by 1 is still 4. Okay, so I need them all to look like fractions so I can see my denominators, and I notice they're not the same. Okay, so then I say, well, is it a 3? Yes, it's a 3, right, because this is just a 1. Okay, so I've got to make both of these denominators be a 3. That means this one's already a 3, so don't change it. But to make this one a 3, I just multiply by 3. So that makes this 12 over 3. Oh yeah, notice that's still 4. 12 divided by 3. Minus 2 over 3. The denominator's the same, so it stays the same in my answer. And then I have 12 minus 2 is 10. I check it to see if it'll simplify, but it will not. 10 and 3 don't have any common factors, right? 10 only has factors of 5 and 2. Okay, let's add some variables in the mix. Okay, it doesn't matter if I have variables. It's still the exact same process. The denominator is not the same, so I've got to make it the same. Is it 5? Does 4 go into 5 evenly? No. 5 and 5 is 10. Does 4 go into 10? No. 15? No. 20. Okay, or you could go over here. All right, and 5 is already prime. So they don't have anything in common. I have to take everything, which gives me 4 times 5, or 20. Okay, so I have to make both of those have a denominator of 20. What do you do to 4 to make it 20? You multiply it by 5. Whatever you do to the denominator, same thing to the numerator. What do you multiply 5 by to make it 20? Whatever you do to the denominator, same thing to the numerator. Now this is 5 over 20. And this is 4 times b is just 4 times b. They have the same denominator. And I can't add these together because they're not alike. It's not like 5 plus 4, it's 5 plus 4b's. All I can do is leave that 5 plus 4b. Right? So even when we add a variable in there, it doesn't really complicate things too much right now. We're going to grow with it though. All right, one more. What if you have a variable on the denominator? Well, it would be the same thing. I need a common denominator. So I come over here. Oh, 3 is already, and so is x. It's just one number. I don't know what it is. They don't have anything in common. So I take everything. That's your denominator. Now, you've got to make both of those fractions have that denominator. So how do you make 3x? Multiply by x. Same thing top that you did to the bottom. What about the x? Oh, it needs the times 3. Same thing top that you did to the bottom. Now that the 3x is common, that's your denominator. And you have 2x minus 6 times 3, 18. Now this was our last example, but they haven't included one. Let's say this was, let me write it in a different color. I want to add one more example on here for us. Okay, what if it was 2x minus 6x squared? Well, I'm going to do the same thing. I'm going to go over here and I have x, which a while ago we said, oh, it's just x. But when I have x squared, what that means is it is x times x, right? X times x. So this one becomes x times x. Take what they have in common. They have an x in common. And this one has an extra x. So here's your least common denominator for this. In other words, this needs a times x, top and bottom. This one already has x times x, so don't change the numerator. Okay. Now that the denominator is x squared, you have 2x minus 6 for the numerator. Okay, so really this is just meant to be a refresher, reminding us how fractions work, right? Just how fractions work, because we need to know that when pretty soon our fractions are going to involve lots of variables. So I need to know the basics of how they work. How do I get common denominators if I can't just look at the numbers and tell what they are, right? Here's our method. So I really want to practice that method, okay? And then, you know, the process for getting equivalent fractions. Okay, let me know if you have any questions.